Hello everybody, Dr. P here. In this video, I will cover Math 10C, Relations and Functions, Topic 4, Example 3 on page 47. In this example, we will be using function notation to determine the domain values. So we haven't really spoken much about domain values yet, so I'll won't be talking about that just yet here. But we can still use function notation to evaluate values for, in this case, it's going to be for x. Okay, so what we have for the independent variable. So what we have here are 4 functions that are given to us. And what function notation allows us to do is it allows us to name our function. So this function over here, if we're going to use just the traditional notation that we have encountered in the past, we might see something like y equals 5x, y equals 2x minus 3, I meant to say, or I meant to write, y equals 2x squared, y equals x squared minus 3x plus 5. So this is how we have encountered functions in the past, y equals something. Of course, the problem with this is that if we're dealing with, like here, 4 different functions, we can't all call them y because there's no way to really distinguish between the functions. So function notation, the term function notation, allows us to essentially give our functions names. Like we have 4 children, we give them different names so we can identify them easier, right? So here are 4 functions. So instead of just saying y equals something, we're going to give them names. So I'm just going to erase this to clean it up a little bit. So this first function here is called f of x equals 5x. The second one is g of x equals 2x minus 3. H of x equals 2x squared, and k of x equals x squared minus 3x plus 5. So now that we have named our function, we can refer to them as, for example, here, they refer to function f, which is going to be this first function right here. Okay. Now, the letter in here, sorry, the number in here, f of 4, the way you read this is f of 4. This represents the value of x for which we want to evaluate this function. What this means is that we're going to take this and replace the x with 4, or we're going to substitute in 4 instead of x. So if we write this out, we're going to get f of 4 equals, so it's going to be 5 times x, but x is 4, so we're just going to set that to 4. And then we write f of 4 equals, well, 5 times 4 is 20. Okay, and that's it. So we've evaluated f of 4. In B, now we want to evaluate g of negative 3. So here's our g of x function. So we're going to write g of negative 3. It means that the x value is negative 3. And then we copy this down, but substitute in negative 3 instead of x. So it's going to be 2 times negative 3. Don't forget to put the negative 3 in brackets. If you don't, it means something different. Minus 3. Okay. So 2 times negative 3 is negative 6 minus 3. Negative 6 minus 3 is negative 9. So we can say that g of negative 3 equals negative 9. Okay. In C, now we want to evaluate h of negative 3. So we're going to write h of negative 3 equals, and the h of x function is 2 times x squared. So it's going to be 2 times negative 3 squared. So negative 3 squared is positive 9. So it's going to be 2 times 9, which is going to give us h of negative 3 evaluated as 18. 2 times 9 is 18. And then finally we have D. We want to evaluate k of 5. So it's going to be k of 5. And so k of x is x squared minus 3x plus 5. So it's going to be 5 squared minus 3 times 5 plus 5. 5 squared is 25. Negative 3 times 5 is negative 15 plus 5. So k of 5. So 25 minus 15 is 10. 10 plus 5 is 15. So k of 5 equals 15. And that's a wrap. Until next time, stay safe, stay healthy, and may the math be with you. See ya.